So here's the twin for Friday's test. He said, don't skip through this. Like quit just looking for answers. Like, it's getting old. Like, why am I taking the time out of my day to spend time on this for you to just ignore it? Quit trying to take the easy route out when the actual correct path is to try to figure this stuff out, and it will be easier on you. Oh, to be young and dumb like y'all. All right, so given log base 2 of 32, in words, what is the question? The question is what power of 2 equals 32? And this is a non-calculator question. All right, you ought to be able to figure this out in your head. The answer is 5. Think about 2 times 2 times 2 times 2 times 2. The answer is 5. That's to do happen 5 times. All right, given log of 1,000. Now, remember, if no base given on log, the understood base is 10. So you got to understand the understood. So it's asking what power of 10 is equal to 1,000. And the answer to that is 3, because 10 times 10 times 10 is 1,000. Not a hard question. All right, moving forward, what is the domain of the ln of 3x minus 5? So you have a rule for logs, and it says for a log with an argument must be greater than 0. Now, that's the rule. I talked about this in the notes at the end of 6.3, I think. All right, so all I care about is the stuff inside the logarithm. Even though it's a natural log, it's still a logarithm. I know that 3x minus 5 has to be greater than 0. So 3x has to be greater than 5. So x has to be greater than what? 5/3. So if I like my set builder notation, all values of x such that x is greater than 5/3, awesome sauce. Or if I like interval notation, 5/3 to infinity. Oops, I don't want hands, I want math. This is just amazing how long it takes to get the actual right guy. Third try, there we go, or 5/3 to infinity. All right, find the inverse, and your instructions are to swap x and y, resolve for y by converting to exponential form. So f of x, which is y, becomes x. It's going to be equal to log of 2y minus 3 minus 5. Now, this logarithm does not have a base given, so it's understood to be a 10. And what I'm going to do is I'm going to isolate the log. So I'm going to add this 5 right here to both sides. That guy's going to get added to both sides. X plus 5 is equal to a log base 10 of 2y minus 3. I'm going to switch over to pen because I can speed up. Now, since the logarithm is isolated, I'm going to identify my pieces. That's the base, that's the argument, which means this stuff has to be the exponent. So I'm going to exponentiate. So I'm going to have 10 raised to the x plus 5, and it's going to equal 2y minus a 3. And now we're going to add 3 to both sides. 10 to the x plus 5 plus 3 is twice y. And I'm just going to divide by 2. So 10 to the x plus 5 plus a 3, both pieces over a 2, and this does not simplify down to anything else. You could break apart the fraction, but whatever, is equal to, since y is now alone, the inverse of f of x. Moving forward, another inverse. This one's an exponential function that we're going to convert into logarithmic form. So same steps, we let y become x. And every time we see an x, it becomes y. And we're going to play the isolation game. We're going to take away 4 from both sides. X minus 4 equals 2 times 10 raised to the y minus 2. And I still need to isolate. I still got this problem. Before you can convert to a log, you have to isolate. So we divide both sides by 2. X minus 4 over 2 is equal to 10 to the y minus 2. And we're going to identify our pieces now. We have a base. I could have swore I picked a different color. We have an exponent, and this must be my argument, okay? So as a logarithm, I'm a log whose base is 10. My argument is x minus 4 over 2, and I would equal y minus 2. And there's only one thing to do, and that's to move that 2 over. So a log base 10, argument x minus 4 over 2, plus 2 is the inverse of f of x. Good old inverses, man. Love them. You invest $50,000 into a savings account that pays 12.9% compounded quarterly. Now, I am not going to let you use this twin on Friday's quiz. You're going to have to learn your formulas, okay? So, not using this twin. The formula is, for compound interest, the amount after time is the principal times 1 plus r over n raised to the nt. And you're just going to feed this thing the stuff you have. So like 12.9% is 0.129, right? Compounded quarterly, you see where it says compounded quarterly? That means n is 4. And then we have our principal. And it's going to be 20 years. It's a really bad looking set of parentheses. Because 20 years, there's t. So after 20 years, I'm going to have my initial 50,000 times 1 plus 0.129 over 4 raised to the nt, so 4 times 20. And this is a button pushing exercise at this point in time. You know, you guys ought to get this if you can remember your formulas. I know that's a big giant if. See, we have 50, 1, 2, 3 times 1 plus 0.129 over a 4. Rooftop to 4 times 20, and if you don't know 4 times 20 is 80, shame on you. But anyways, 63,000, no, 633,000. Yeah, it's 13% interest. 633,521. And how many pennies? 46 pennies. Not bad. All right, what rate of interest is required to quadruple? Quadruple means to multiply by 4. An investment of $20 in 8 years if the interest is compounded continuously. So I saw the word continuously, so I'm going to use the formula for continuous interest, HERT. And Olivia, pay attention that exponents are high and small. You keep writing them on the same level. So this is my principal, and if I'm going to quadruple, after time passes, I'm going to have 4 times 20, which is $80. Yeah, I'm just going to plug some stuff in here. By the way, this is time. So after time, I've got 80. I start with 20, and I have e to the r, which is unknown, but I do know this is 8, because time is 8. Now, we can actually do this by hand. This is not a problem that you have to use a calculator on. I'll show it in the calculator so you can agree that it's right, but divide both sides by 20, isolate the e. We would have 4 equals e to the 8r. I'm just going to rewrite that so it looks better. And then I can go through and I can convert it into a logarithm. I have a base, I have an exponent, and I have an argument, right? So this is a log whose base is e, its argument is a 4, and it would equal 8r. Divide by 8. Now log base e is known as ln, the natural log. So the ln of 4 over 8 is my rate of interest. So let's see what happens. So doing this by hand to some degree, I got 0.1733, which is 17.33% interest. Now, if this was too much for some of you, you could have Y1'd and Y2'd it. And I'm kind of okay with that, and I'm kind of not. But some of you guys are mouth breathers, so let's just go ahead and see what happens. I mean, it's not going to kill you to learn how to use a TI-84. All right. Zoom 6 like you were taught. Of course, it doesn't do any good. Once mine finishes, I'll go to the Windows settings. Let's set the Y max to be 100 because I put an 80 in Y1, so pretty sure 100 is bigger than 80. And the answer ought to pop up immediately. It should be somewhere in here. Second trace. Second trace. Try that again. Second trace. There we go. 5. Enter, enter, enter. So you see the same exact answer. Same exact answer. Now I can always strip calculators away too, so be in mind of that. You borrow $35,000 to purchase your first car, not wanting too high a monthly payment. You take out a 7-year loan if the interest rate is 7.3% compounded monthly. And again, you're going to use the formula for compound interest. The amount after time is the principal times 1 plus the rate over the number of times interest is compounded per year n, raised to the nt. All right, so the principal here is $35,000. Doing a 7-year loan, time is 7. Monthly, n is 12. And the rate is 0.073. Don't be the kid who can't convert that to a decimal. Like, I can't help you. I can't. You have not paid attention your entire life to anything. All right, so what will be the entire amount? We're plugging in a 7 everywhere you see a T. The amount in 7 years is the principal of 35,000. 1 plus 0.073. Sitting pretty over n, which is 12. Raised to the nt, 12 times 7. If you don't know that's 84, so be it. TI-84 ain't going to judge you. It's not going to. Notice that Milbrath types the whole blasted thing in his calculator. He doesn't figure out little pieces here and there like some of y'all do. You shouldn't do that because you're rounding. You don't round until the end of an answer. Learn how to use your calculator. These things are amazing. They're way better than what I had when I was growing up. Appreciate that. $58,253.26. 58,253 and 26 cents. Look at that. Like you're spending $23,000 in interest to get this car. Like, make that connection. You should really only buy what you can afford. I wish I would listen to that advice sometimes, but you can really only buy what you can afford. What will your monthly payment be? It is a 7-year loan. So 7 times 12 is 84 months. I notice a couple of y'all are missing like that little detail on a quiz. RTFQ, read the full question, okay? So I'm going to take my $58,253.26, and I'm going to divide it by 84. I'm going to get $693.49. Sorry, I didn't get a number. $93.49 per month. Ta-da! All right, halfway done. Solve 3e to the negative 7/10 of x plus 3 is 33. And we're going to do the way Milbrath teaches. We're going to do easy things first, right? That's how I've taught these things. So the very first thing I'm going to do is I'm going to take away 3 from both sides. That'll give me 30. Then, and by the way, notice I talk about get into the right form. You have to isolate the base. You have to. So we're going to divide out that that positive 3. And 30 divided by 3 is 10. Now we're going to do the whole log as bay thing, all right? So if I look at what I have, my base is e, my exponent is negative 0.7x, which means my answer is 10. And I'm going to do log as bay. I have a log whose base is e, its argument is 10, and it equals, and well, this is going to look kind of funny, but negative 7/10 of x. The reason I wrote that as a fraction. Just write it in exact form. Now, log base e is known as ln. So I have the ln of 10. I'm going to divide both sides by negative 7/10. Now, go back to like middle school, doing a half divided by 3/5. Well, that's a half times 5/3. We multiply through by the reciprocal. So I'm going to multiply this thing by negative 10 over 7. Negative 10 ln's of 10, sitting pretty over 7, is my x value. I know that's going to bug some kids. I know it is. I'm sorry you didn't comprehend 5th grade math. I really am. Why you were promoted past 5th grade blows my ever-loving mind. You should go back to 5th grade. Number 10, solve log base 4 of 2x minus 5 is 3. Give your answer in exact form and as a decimal, if needed. So this is my base, this is my argument, and this must be my exponent. So I'm going to have 4 cubed, we're doing a process called exponentiating here, equals 2x minus 5. We're going to do easy stuff. We're going to add 5. By the way, 4 cubed is 64, and we're going to add 5 to both sides, so that'd be 2x. 64 and 5 makes 69 equals 2x. And I guess we're going to divide by 2. 69 over 2 is x. So there's the perfect form. If you want that as a decimal, it'd be what, 34.5? So easy peasy, lemon squeezy. A pesticide kills 15% of all bugs every 12 minutes. Determine the hourly rate. Notice it talks about kills, that's decay. And your form for decay is the amount after time passes is principal times 1 minus r to the t. Technically over the time period. Okay? That's time period. This one's not singular. So let's do a per 12-minute one. After some time passes, we have the principal, which I don't even know what it is, times 1 minus 0.15 to the t over 12. So 1 minus 0.15 is 0.85. I know some of you wonder where I get these numbers from. It's because I know how to add and subtract. And you don't. Because I don't know why you got promoted. So this is a every 12 minute. That's what that is. That's an every 12-minute model. I want the hourly kill rate, not the every 12-minute kill rate. So this is going to be kind of interesting here. I need to take that t over 12 and make it an hour. And it's not that hard to do because an hour is 60 minutes, right? So we're just going to put a 60 in there, 0.85 to the 60 over 12. That's all we have to do. Put that 60 in there. Let me erase that so it looks a little better, because you're probably watching this without audio and you're probably just flashing through to the answers. And let's see what that is. I'm not asking you to rewrite a function. I'm just asking you to find the hourly kill rate. It's actually a really fast pesticide, by the way. There's something with residual. .4437. Now, This is not the hourly kill rate. This is what's left. After you do this, you have 44.37% of the population left. Think about how this was originally 1 minus R. We're saying 1 minus R is 0.4437. That's what's being said. So we're going to shift some things around. 1 minus 0.4437 is my rate, which is 0.5563. I feel pretty good about that, which would be 55.63%. That is your hourly kill rate. And you know, that problem required kids to think about a couple different situations, so it's going to be a little rough on some of y'all. Use your brain, kids. Answer the full question. Read the full question. You know, don't be a simpleton. All right, these next two are old. Given f of x is the root of 6x minus 4 and g of x is 2x plus 2, find f of g of 4. So we're going to work our way out. So we're going to find g of 4 first. So we're going to plug a 4 into g. G of 4 is twice a 4, add a 2, which is 10. And since this literally became 10, we find f of 10. So we're taking a 10 and putting it right there. So that's the root of 6 times a 10, and inside that radical is still a 4. So that's the root of 60 minus 4, which is 56, which should simplify, I think. I feel like it simplifies. 56 is what, 4 times 14? And the root of 4 is 2, so 2 roots of 14. That's your answer. Given f of x is x squared plus 3x and g of x is 2x plus 4, find f of g of x, or f composed of g of x. Better written as f parentheses g parentheses x close parentheses. We're going to take this and we're going to put it right there, and we're going to put it right there. So we have a 2x plus a 4 that is squared, plus a 3 times a 2x plus a 4. And you know full well that if you're going to square something, you're going to write it twice because you're not going to listen to Satan. We have that mean, remember. Use the distributive property here. 2x times 2x is 4x squared. 2x times 4 is plus 8x. 4 times 2x is plus 8x. 4 times 4 is plus 16. And then we combine like terms. There is a 4x squared. 8 and 8 is 16, plus 6 more, plus 22x. What do I have here? I have a 16 and a 12, so plus a 28. And that is f o g of x. 2 more to go. So consider the function f of x is 6x cubed minus 9x squared plus 54x minus 81. You're supposed to find all the zeros of this function. So what you're going to do is you're going to go to your TI-84 and you're going to get the real zeros. Let's take a look at the graph. Oh, I forgot to do zoom 6. Oopsie poopsie. This kind of stinks. Oh, okay, that's not bad. I'm going to put a 0 in there. I want to make sure that that's 1.5. See, second, trace, 5. Enter, enter, enter. Yeah, 1.5. So from the graph, x equals 1.5. Well, let's do a little synthetic division. 1.5, coefficients are 6, -9, 54, -81. Do a little DMA. We're going to drop that 6. 6 times 1.5 is 9. -9 plus 9 is 0. 1.50 times 0 is 9. 54 plus 0 is 54. And 1.5 times 54 is 54 plus 27, which happens to be 81. Remainder of 0. This is my remainder, my constant, my x squared. I am left with 6x squared plus 54 equal to a 0 because there's 2 more zeros. I am going to subtract 54, and then I'm going to divide by 6. And 54 over 6 is 9, so x squared is -9. I'm going to counteract a square with a square root, and the square root of -9 is plus or minus 3i. 0, 0, 0. 1 plus 2 is 3. Third degree polynomial, fundamental theorem of algebra. Express your zeros using function notation. Now, I like this written as 3/2. So f of 3/2 is a 0, right? F of 3i is a 0, as is her conjugate, -3i. Easy peasy, lemon squeezy. And the last one, by hand, graph f of x is 2 times 3 to the x minus 3 plus 2. Talk about our shifts. We have a right 3, and we have a up 2. Right 3, up 2. Now this line right here, this y equals 2, that is my horizontal asymptote. It's at y equals 2. I cannot cross that line. Because I went right 3, when I make a little table, I'm going to start at 3, and then I'm just going to also move up by 1 and do a 4. And I'm going to feed this function those numbers. So I feed this function a 3. This is what's going on in my blank piece of paper in my mind. I plug in a 3. 3 minus 3 is 0. 3 to the 0 is 1. Times 2 is 2. 2 plus 2 is 4. Then I feed that thing a 4. I have 2 times 3 to the first. Anything to the first power is itself. So just 2 times 3, that's 6. 6 plus 2 is 8. And these are my 2 points on the graph. I contain 3, 4. And I contain 4, 8. And I'm an exponential function that grows over time, but I can never, ever, ever hit that asymptote. My domain is -infinity to infinity. My range is 2 to infinity. And notice that this was not only the range, it was also the horizontal asymptote. There you go. Busy morning.